All right, y'all, let's take a few minutes and look at some tools that we can use to turn the pixels on our screen into shapes on a page. And by that, I mean extracting line work from 3D models in Rhino. But before I get started, I'm going to talk about something that's like a little bit dry, but super, super important. So the first thing that you need to know is that if you want to extract line work from something, the lines actually need to exist. So by that, I mean, let's take a look at this. I'm going to illustrate this point by using a tool that you may have already seen before, which is called Make2D, which is kind of the go-to for extracting line work from for making 2D drawings from 3D shapes in Rhino. Now, this tool exists in different forms in lots of different softwares. It's just called this in this software. But to illustrate my first point, I'm just going to make a box. I'm just going to say it's like a 1 by 1 by 1 box. Cool. And then I'm going to copy this, paste it, and I'm going to maybe resize it a little bit so this interaction is a little more clear. All right, and I'm just going to smash it right through the surface of this thing. Now, this box and this box are crashed into each other, but there's still two distinct things. So if I want to make a 2D drawing of this shape, then I know that all of these edges where these boxes are real things, but this thing where they just crash into each other, there's not actually an edge there. That's just where stuff just crashes. So the reason that this is important is if I make a 2D drawing of this, and I say make 2D, and I say sure, then if I look at what that drawing looks like, that edge is not there because that edge is not there in real life. And in fact, I get actually a really sloppy drawing of this thing. It's kind of confused about what's going on there because it's actually a little bit unclear as to whether or not this is one or two things because they're just two things occupying the same space at the same time. If I want this to actually resolve, I need to make sure there's really an edge there, which I can do in a lot of different ways. In this case, I'm just going to do a Boolean union and make sure that these things are in fact the same object. You'll notice now that I'm seeing a clear edge there, and that when I do my make2D command, I should get a drawing that looks correct. And I do, so I get a much better drawing. So if you want curves or lines to show up in your 2D drawings, they need to actually exist in your model. Or you need to use a different tool that will extract geometry from those intersections if they don't actually exist. And those are tools that we're going to look at more in this video, but that's a fundamental concept that will help you decide which tool to use and to help you debug your drawings. And you should know that before you even get started. Another thing that we need to look at before we even get started is your tolerances and your units on your computer. So let me wipe this stuff out because we don't need it. Get over here, out of there. Let's get back to this guy here. And this is a concept that if you've ever worked in data science or statistics or in a machine shop or read a blueprint, it's going to be pretty familiar to you, and its importance will also probably be apparent. But this is the idea of units and tolerances. So depending on how you set up your file, if you just choose the default settings, sometimes they might not be what you need. One of the default settings in Rhino is for your units to be feet. So if I look down here, I can see my units at the bottom of my screen. I can also right-click on this and go to Unit Settings, and I can see that my units are in feet, and my tolerances are 0.01 units. This is actually pretty big if you're working with something small. So if you're in my studio or in an architecture program or whatever, which is of course the intended audience of this video, chances are the materials that you're working with are pretty small. Even if you're working at building scale, lots of little building materials are way smaller than this because 0.01 feet is almost 1/8 of an inch. 1/8 of an inch is thicker than a lot of stuff. So if you're in an architecture studio and you're doing a bunch of stuff with 1/16 inch chipboard, a 1/16 of an inch is smaller than this tolerance. And the reason that this matters is because if I go and I make something like, let's just say I draw this line, right? And if I copy this and paste this and I move this over 1/16 of an inch, on my screen, it looks fine. I can see two lines there. So maybe I'll make them look even more proportional so this won't look like such an extreme example. So let's just say I've drawn something like this, right? Maybe I'll even do something like make two boxes that are this closer together. So I could even do something like take this guy and extrude this way and extrude this way, right? So these are two different things. If I go here and I tell it to make a 2D drawing of this, whatever this is, it's going to make this, and if I go look at what that drawing looks like, it doesn't look right, right? It doesn't know what to do with this line because as far as it knows, these two things are in the same place. Now, to put an even finer point on it, I'll go back to this original drawing here and I'll do a make 2D of just this. So I've got two lines. If I get that drawing, I end up with a drawing of one line. Now the reason that this is happening is because if I go back to my unit settings, remember my units are feet, my absolute tolerances are 0.01 inches, and those two lines that I drew were a 1/16 of an inch apart, which is less than this tolerance. So if you're working with something small, let's change our units to something small. Make sure you read that dialog box when it pops up, depending on how you have your model set up. Let's go ahead and change unit system only. Say apply. And let's go ahead and make this even smaller, just in case you're working with something real tiny or have some geometry that's really close together. So now if I go back to my image and make my drawing again, let's try this one more time, and let's see if we get what we want this time. And I do. I get a nice drawing of two lines because now, as far as my computer knows, those lines are actually in two different places because they're not within tolerances of each other. This is another really important thing for debugging your drawings and for talking to your computer correctly, not just in this software, but in any of them. So before we get into the fun stuff, let's get the really important concepts down pat. All right, now that we've got that out of the way, let's look at some things that we can use to extract line work or curves from our 3D models. Let's go back to perspective. Let's zoom out here. Let's make sure our units are something usable. Let's wipe out this junk and let's get cracking. So I'm going to go ahead and I'm going to start with just a basic box just for the purposes of this tutorial. And I'm just going to say, let's just dump it right there. You can also control where you dump these things. So if I go back here and I say, repeat that last command, and I say that the first point is 0, 0, 0. You don't have to specify an origin, but if you want to, you can do it there really easily. And you can also just click and drag this thing to specify size, but if you want something specific, then you can enter these measurements here. So let's say it's just like an inch by an inch by an inch. And remember, I know it's inches because I changed my units to inches. Cool, so now we've got a box. Let's see how we can grab some curves from it. The first thing I'm going to show you is the duplicate edge command, which is DupEdge, right? Okay, so now I can select edges to duplicate. I can say enter. Check it out, there they are. Now they'll come in as separate things, so I can join them if I want to. If I want to make something else out of that, I can take these guys, I can, extrude them if I want to. They're just going to be an open surface because those were two open curves. So that's one way that I can quickly duplicate the edges of an object and make other things out of them. Okay, another thing you can do is duplicate the borders of an entire face. This is super helpful, and I'll explain why in a minute. So if I simply run the command duplicate border, which is DupBorder, and say this, it's not going to work because no borders are duplicated because that wasn't a face, that was an entire object. So the way that I need to do this is to use a handy dandy command, which is, it's not really a command so much as it is a workflow. And if I hold down Command and Shift if you're on a Mac, or Control and Shift if you're on a PC, Control Shift, I can select the sub-object of an object. So like I can just select the face of this cube because right now this is one object, but then Control Shift will let me select just this face or just this edge or just that corner. And now I can manipulate those things or extract geometry from them. So, this is handy when you're modeling if you want to move this over just a little bit, or if you want to change the shape of this just a little bit. And I can do that in a very controlled way too. I can, if I want this corner to kick out like an inch, I can have it kick out an inch just like that. So you can change things just like, by manipulating the object. So if you're used to working with something like SketchUp, then this workflow will probably seem pretty natural to you. Anyway, Control Shift, duplicate border. Cool, now I've duplicated the border of that whole thing. This gets really handy as you can start to get really complex borders. So if you're doing things like setting up a model for laser cutting and you want to duplicate the entire face of an object and have like different things cut out, then this is really handy. So just to kind of put a finer point on that, I'll do a Control Shift, and I can use, this is a cool thing that's been introduced since Rhino 8, inset. I can say I'm going to offset from that face by, I don't know, 1/8 of an inch. Cool. Now I've got another face in there that I can grab with a Control Shift, and I can extrude that. And now I've got this little handy dandy thing that's been made out of this object. And now if I run my duplicate border command, boink, Control Shift, grab that face, cool. That's the border of that thing. So this is like pretty helpful if I'm trying to extract borders from things that start to get kind of a little bit complicated. This is obviously not complicated, but you can imagine that if this were an architecture model and this were full of window, all those little squares would get captured, and you'd be easily able to capture the geometry of this surface with that one command. Okay, cool. Let's go on to another command, which is to extract the wireframe of this object. So if I want to get not just the boundaries of a face, but the boundaries of the entire object, then let's click on this and let's say extract wireframe. And this is going to give me the wireframe of this entire object. Now you'll see with this, I've also got these lines that don't actually exist. These are the isocurves of the surface, which I have turned off in this view. So if I don't want that, and I just want the entire object, then I'm going to go ahead and do it. Let's do a Control Z, Control Z. Let's change our display properties. So I can do this by going into my display properties over here, and I can say, oh wait, now I remember. If I click on this guy and I check out its properties and I say, don't show surface isocurves, and then I can do my extract wireframe, and I'll end up with something much cleaner. All right, let's delete these guys and let's look at some objects that are a little bit harder to show. So let's go ahead and look at something like, I don't know, maybe a cone, or maybe even a sphere. All right, cool. So this is one of those things where there's not really an obvious way to extract curvature from it because there aren't any obvious curves, but this is something really easy to do if you use a command like extract isocurves. So isocurves, there we go. All right, so here's our surface. And you can see it's allowing me to, it's showing me a curvature that it can create a curve from in this direction, or if I want to change in this direction, or in both directions. So if you want to go ahead and grab this, then you can extract curvature from this thing however you want. Let's just go ahead and just say yes. If I delete this original object, you can see that my curvature is right there, and I can use that just like, you know, any other curve in my Rhino space to make new shapes from or to make a drawing from. Now, if I do want to make a drawing from this, remember this is still a 3D thing because it extracted those things in 3D space. It is very easy to make a flat drawing from this using that same technique we've already looked at, that make 2D. We'll then flatten that drawing on the top plane, and you can see that that drawing is just a flat representation of that. And you can use all of your usual 2D editing tools to edit that drawing if you'd like. Another way to do that same thing is to use a command called intersect. Now with this one, instead of drawing a indicating where a section line is and then having it disappear, this is a nice way to kind of just calculate the intersection between two objects. And this is a really good way to draw a section also, but it's more useful than that too. So just to be a little more clear, I'm going to go to the top plane. Maybe I'll grab a line. Cool. And then maybe what I'll do is turn this line into a plane. And I'm going to do this so that I completely intersect the object. That is an important part. Cool. So now if I want to draw a section, then it's really easy to kind of use this to visualize where my section plane might be and do something like an intersect command and say, find the intersection of this. And there you go. That's my section. So you can sort of imagine then if you were going to do a collection of section cuts, you might do something like, you know, move that plane around and do that intersect command again. Command, intersection of this and this. There we go. And I can keep extracting intersections from there to there. Now, one thing that also might be helpful if you're doing a drawing and you want to have, you know, indicate where all these section lines are, maybe you want to just kind of, whoops, sorry, copy and copy, paste that plane, and then, you know, I can leave these planes in place. Copy, paste, copy, paste. as a visual aid. So then if I did something like select all of these guys and say intersect, then I can kind of see where all those intersections are and the original planes that made them. So if I wanted to make a drawing where I kind of indicated where those intersections were, then I might take all these little curves and then connect them with a line to indicate where they've been extracted from. Or if I wanted to add section lines later, I know where to add them. You don't have to do this, but this is a handy tool. Now, it's not just for drawing, obviously. If you want to calculate these intersections to split things, so for example, if I wanted to do something like, let's go ahead and say intersect. I can't spell today. Now what I can do is I could do something like, let's get rid of these just so it's easier to see. Maybe I want to split that sphere with all of those objects. Curve, 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 curve. And now I've got this thing that's all sliced up, deli slicer style. So it's not just for drawings, it's also for cutting stuff or manipulating geometry in different ways. Okay, another handy thing that we can look at here after intersection is intersection again, because it's not just about planes and surfaces, right? You can do this between objects. So let's go ahead and let's use something that's easier to visualize than a sphere. I'm going to go back to my boxes again. Copy paste, move this up, flip this around, maybe give a little spin here. Make sure these crash into each other in a nice way. So what if I wanted to figure out what that curve looked like where these things are all kind of smashed together? Well, this is a great place for that intersect command, because remember, there's no actual curve there. These boxes are just crashing into each other in space. So if I wanted to create something from this boundary, or subtract this front box from the other box, then intersect command would give me a visualization of what that boundary looked like. So intersect, cool. You can see what that just created is that created a curve where these things intersect, right? Which looks like this. This is actually really helpful. So if I do something like use that same intersect command, intersect right there, and I then split this box with the curve that I just made, right? Actually, let's really quickly select the last curve that I just made, and let's make sure that's all joined together. And then if I say U split with this curve right there, done. And then I split the other one here with the same curve, which should work because this curve should perfectly intersect both of these, done. And I can say like, delete this, then delete this, then this surface got cut off of that one, join it. And now I've got a closed model that will actually, that has that thing cut out of it. So it's a really hard shape to make if you try to make this on its own, but if you need to subtract one geometry from another one, then that's how you can do it. Now, this command is all, what I just did was essentially a Boolean difference command, but step by step. So again, if your Booleans are failing, just do that, and that should hopefully make it work. Okay, let's look at one more version of intersect that's a little more nuanced, but that can sometimes be kind of useful. And so what that is a command called IntersectTwoSets. So let's say I wanted to know where the circles intersected with the squares, but they're all just loose objects. What I don't want is, if I just run the command intersect, then what that's going to do is it's going to give us everywhere that everything that I just selected intersects, not just that one connection that I was talking about. So that's kind of like not super helpful. There's a command called IntersectTwoSets right there, where I can just isolate particular sets of objects. So here I've got one set of just the boxes, say done, and then this is my other set of objects, and it will calculate just the intersections between the two sets, not the individual objects with each other. So that can be helpful sometimes. So if you've made it this far, I've got a little bit of a treat. So we may or may not have already looked at this point in the semester, the use of a command called clipping plane. And clipping plane is really helpful because it lets you cut a live section through a thing. So clipping plane. Cool. There's lots of ways to draw this. I'm just going to be really simple about it and just draw a vertical one. So it's going to ask me to draw a line for reference. And what this is going to do, this is going to create a live section plane that I can move through my stuff, right? Okay, cool. So this will help me choose where to cut a cool section or to extract a particularly useful bit of geometry, and you can kind of fine tune it visually. Now, there's not an obvious command that would allow you to extract the geometry of whatever this border is, except there actually is a really easy one, and that is, there's two versions of it, and one is called ExtractClippingSections, right? And so what this will do is this will extract, if I select that last thing that I just made, whoop, that is all of the stuff that the clipping plane just cuts through. Now you can see that because these are all just loose objects in here, that section looks really crummy. So there's a really easy way to clean that up, and I will show it to you in just a second. The other version of this command is ExtractClippingSlices, which does the same thing except for when it extracts the stuff, like last, it will give you surfaces instead of just curves. So basically the same thing. These obviously are all self-intersecting. This is a little bit of a jumble. If you wanted to make a nice clean shape out of this, then check this out here. Hold on, this is really helpful. Let's grab all this stuff and let's look at this in a different plane. So let's go over here and look at it from the front maybe. Is that what I wanted? Yeah, it is. Cool. How do I clean this all up? Well, it's really easy. I could just select all this and say trim and easily clean some of this junk up and then make this into a nice clean surface, a nice clean curve, right? So I could do all this and then grab you and you and you and you and then say done, and then join all of that, and then I can use that to create a new shape if I want. Cool. The other thing that I can do if I want something that's a little bit more like an Illustrator thing, there's a command called select all this, curve Boolean, and I can select what I want to keep from all of this gibberish. That looks pretty good. That looks good too, sure. And it'll make me a new curve out of all that stuff. Cool. All right, okay, and last but not least, there is one more command I want to look at together, and that's contour. So what that's going to do is that's going to create slices of your object at a regular interval. So let's go ahead and knock this stuff out too. Delete this, delete this. I don't need you anymore. All right, so let's just go ahead and, so these are all different objects. Let's make them all one thing. Boolean union. Cool, so now they're all one thing. Let's go ahead and contour this guy, and I'll show you how this works. It's kind of like a deli slicer where it kind of runs through and creates a sort of, not literally slices, but it creates the boundary of that object at regular intervals. You can kind of see how that looks if I write contour. This is super, super useful. Let's say I'm going to contour this thing here, and I'm going to select a base point. Right now what I'm doing is I'm defining the directions the contour gets, the slicer slices. So I'm going to say let's slice vertically by going along this vertical edge. Maybe my distance between contours is, I don't know, let's just say a 1/4 inch. All right, so what that did is it created a slice every 1/4 inch of the boundary of my object. And because all this stuff is one object that's all Boolean together, you can see that my contours are just the exterior edges. You can also see how I could use all of these curves together to make a sort of model out of this if I wanted to. If I wanted to make a model of this from like stacks of cardboard, I could do it that way. One thing that's important about using the contour command is you do need a pretty clean model for it to not look terrible. So for example, if I go back through and I undo my Boolean union and leave all these things loose and run my contour command again. Base point is, whoop. Let's go ahead and say that's my direction. Again, I did that because I know that model, I know that this thing is flat. If you don't have, for example, if you've actually, let's go ahead and talk about this for real quick. If you don't have a model that's got a nice vertical edge, so let's go ahead and make this kind of weird and abstract, and you want to contour this vertically, which is super helpful if you're going to make it out of something like, you know, chipboard or cardboard or whatever, or you can control the direction of the contours by just using another object as a reference thing. So let's say I want to cut this thing in perfect vertical slices, but I don't have an easy to select edge on this thing, then what I can do is I can say contour this and say my base point is in this direction along that nice straight vertical edge. And even though that has nothing to do with the object itself, you can see that my contour lines, if I look from the right, are perfectly vertical. But even if I didn't have a vertical edge to select when I first started. Now, one of the big differences between this and the original model that I just showed, that we made a minute ago, that was nice and clean. Let's go back into that nice straight one, is you may recall that if I contour, base point, 0.25, let's look at this thing before this stuff is all Booleaned, or joined together, and let's join it all together with a Boolean union, and now let's go to contour again. I'm going to get a different result. So see how much cleaner this is? This is because all of those things were joined together, so it just got one big outside surface here. When you have just a bunch of stuff that's loose and intersecting, you're going to get all those shapes of the individual objects captured and all the intersecting edges, which might not be what you want. Maybe it is, but just think about what it is that you want before you run that command and make sure that you're working with something that will give you the desired result. Otherwise, think about using a different command.